Hi gents, we're gonna continue on just with functions. We had an injective, surjective, bijective video that you tried out a couple of tricky questions on. So this is continuing on from there with functions. It's not to do with injective, surjective, or bijective. It is instead to do with inverse functions. So I'll just explain what an inverse function is first of all. So I have a nice example here that somebody sent me in, just wondering if I would go and do it. So I'm going to use this as our example in a minute, but first I'll just sort of show you just over the side maybe a generic problem. So it's typically you're given f of x, or you can call it y if you want to. I'll call it y just for the time being. So we'll just make something really trivial. We'll say y equals 2x plus 1, something like that. Okay. Now what you could do is you could make a little table of input and outputs. Okay. So for instance, if we input in 0, so that's our x value, typically is what we call it, that's our y value. If we input 0, we're going to get 1. If we input 1, we're going to get 3. When we input 2, we're going to get 5, and so on and so forth. Okay, the inverse function. So if this is f of x equals 2x plus 1, there will be two ways to write down the inverse function. Just as notation, it would be the inverse function of x, written like that, or the inverse function of y, sometimes written like that. Now, one thing that you can get confused about is just immediately say, oh yeah, maybe the inverse function just means that I do 1 over 2x plus 1, and that is certainly not a bad guess if you've never seen it before, but that is not what it means. An inverse function means this. It means that when I put in 1, I got out 3. That's with this function here. The inverse of that function would mean instead, if I put in 3, if I put in my output as an input, I would get my input as an output. So for instance, when I place in 1, I get out 3 for this function up here. With an inverse function, if I place in 3, I will get out 1. And the inverse function will also be such that if I input 5, I will get out 2. If I input 1, I'll get out 0. So if I ask you to, pause the video for 3 seconds and try to figure out what would that function be, what is the function, such that if you put 3 into it, it'll get 1. If you put 5 into it, it'll get 2. If you put 1 into it, it'll get 0. And the same for all that table there. And if I should try, but I wouldn't spend more than 30 seconds on it. Okay, if you did, you probably found that it's not the easiest thing in the world to just think up. But thankfully, this topic is actually very easy to get the right answer for. Well, certainly with this trivial example here. This is what you do. Whereas with all functions, you get y equals, and you can then just fill in your input. Instead, what you want to do is you want to manipulate the same formula, so you get x equals. So we'll do that here. Y minus 1 is equal to 2x. And we get that x is equal to y minus 1 over 2. And suddenly we've flipped it now from being that the output was the subject of the equation to the input being the subject of the equation. And now if you swap x with y, if you literally just do a swap, if you call this thing x minus 1 over 2, and if you call that thing y, this is the inverse function. Okay, we'll write it as f of x equals x minus 1 over 2, or y equals x minus 1 over 2. And you can, and should, just check now, okay, if we place in 5 in here, are we going to get 2? Well, 5 minus 1 is 4, 4 over 2 is 2. If I place in 3, am I going to get 1? So 3 minus 1 is 2, divided by 2 is 1. And if I place 1 in, I do get 0 over 2, which is 0. So this thing here, this is the inverse function, is what we would say. Okay, so that's what you would do for an inverse function. The plan again is, instead of having y equals, it is to go and get x equals. When you have x equals at that exact moment, change x into y and change y into x, and there you have it, the inverse function. So what we'll do is we will just go and get the inverse function of this thing over here. Okay, this is one if you're if you wanna just pause the video and try and get it. So it's trickier for sure, because you can see that there are two x's in there. So just remember, we want to get x equals, and there should only be one x equals, and on the right hand side should be y's. There should not be, y's and numbers are fine, but there should not be an x over on the other side. So that's very, very important that you have that there. So in this case, pause it, try and isolate x on its own. Okay, let's see, how do we get on? So this is certainly trickier than the previous one that I gave you as an example, but hopefully you were still able to do it. Correct thing here is to multiply both sides by x minus 5. Y times x minus 5 is equal to 3 minus 2x. Actually multiply it out. That's maybe something that we might have a slight hesitancy to do, because we don't typically like to have y by x and stuff like that. That's you know, typically it means that you're not going terribly right in previous questions, but in this case it's absolutely fine. What you want to do is you want to remember get x on its own. So bring all the things that have x's to one side and bring everything else to the other, and now factorize an x. If you factorize the x, you'll get y plus 2, and it's equal to 5y plus 3. Now we can divide both sides by y plus 2. You must make the next step. Okay, it's not good enough just to stop there and go, yes, that's it, I've done it. You must now say, and this is going to be your answer, the inverse function is that y is equal to 5x plus 3 over x plus 2. And I would always take the time, and I might write it like this for them. I would always take the time here just to double check it. Pick a value, send a value in here and see what you get. So let's say that we put in 1, for instance, or 2, we'll say 2 here. So if we let x equals 2 here, what are we going to get? So we'll just do this over here. So we're going to get 3 minus 4, so we get minus 1 on top, and we're letting x equals 2, so 2 minus 5 is minus 3, so we end up getting 1/3. So what we're saying is the input is 2, output 1/3. So it should now be the case that if we go down to our inverse function, okay, whichever one it is, they're both the same. It should now be that if we input 1/3, we get out 2. And if we don't get that, this definitely isn't the inverse function. So let's do that. 5 times 1/3 plus 3 over 1/3 plus 2. So we have 5/3 plus, that's going to be 9/3 over 1/3 plus 6/3. How many thirds is that? That's 14/3 over 7/3. Yeah, and I think that we can see if we multiply top and bottom by 3, that's 14 over 7. That's 2. So when I've placed in 1/3, I get an output of 2, and that doesn't prove that that we've got the right answer, but it's very strong evidence that you've got the right answer. If that was different, then you know that you're wrong. In this case, it could be a gigantic coincidence, albeit that's very unlikely. So it's pretty good. It's pretty good evidence that that's the case. Okay, I'm going to pause here and Okay, we're back here, and what we're going to do is we're going to have a little look at this function here. So this is an unusual function compared to most of the ones that you've seen. I think we have seen one of these before, but I will explain it as if it's totally new. So this is a function that behaves differently at different times. Okay, you might think of it as two functions because it acts differently in two different places, but really it's just called one function, but it's sort of split into two. Okay, so what it's saying is that it's linear in between 0, 2, or sorry, 2, 0, 2, 0, and what's that, 8, 4. Okay, if it's linear, we know that we can just get it by y minus y1 equals m times x minus x1. Well, let's just go and get what the slope of it would be. Okay, slope is rise over run, so how much has it risen? Risen by 4. How much has it moved over? It's moved over 6. So we're dealing with a slope of 2/3. So we'll just take x1, y1 to be this. So we get y minus 0 is equal to 2/3 of x minus 2. So we get y is equal to 2/3 x minus 4/3. Okay, that is what that is the way it behaves right there, but it behaves differently from here to here. So in this case, I'll maybe do it over here if I can manage it. That's minus 1, 9, and it's 2, 0. That's our x1, that's our y1, that's our x2, that's our y2. We'll again get the slope. So how much do we move over? We moved over 3. And how much do we move up? We moved up 9. So its slope is 3. So we get y. I think I will choose my x1, y1 actually to be this one here. It's just a little bit easier. So y minus y1, so that's y minus nothing, is equal to m times x minus x1. So we get y is equal to 3x minus 6. So the way in which you would write this function, they don't ask you to do it here, but I just want you to be aware, the way that you would write this function is you would say this: f of x is equal to, when we do a bracket, okay, so it's equal to two different things at two different times. It's equal to 3x minus 6 when x is between, including, minus 1 all the way up to and including 2. Okay, and instead it behaves as if it were 2/3 x minus 4/3 when x is greater than, it also is like that when it's equal to 2. So you could, if you wanted to, let's see if I can do this without killing it all. Yeah, you could instead put that one there. It doesn't matter which way you do it. I've included in that one, so we'll just keep it there, all the way up to and including 8. Okay, that's what you say. So it behaves like this in one section, and it behaves like that in the other section. I will give you, at the end of this video, I'll give you a specific question that I want you to try out that actually goes through a lot of those ideas, and I'll make another video on it there. Okay, write down the range of g. So the range of g is just going from the lowest value to the highest value, but normally, you know, in statistics, you know, if it goes from 2 to 10, you say the range is 8. In this case, you don't. What you say is you say it goes from this to this. So the lowest y value that you have is minus 9, and the highest y value that you have is 4, and you leave it like that. Okay, you write it like that. The square brackets means that it goes to that exact value. If it was up to but not quite that value, if it was, you know, if it goes to minus 8.9999999 or something like that, then you would write a curly bracket. But square bracket means it goes up to that exact thing. So write down the range of g. Done. Okay. Find f of g of 8. Okay, find f of g of 8. So I'll just talk about this one here. This one is actually quite a simple one to do, but we should talk about, like, we'll just make up an example over here. Okay, so we'll say that f of x is equal to 2x squared plus 1, and we'll say that g of x is equal to, thanks Killian, we'll say that g of x is equal to, we'll try and pick something easy, 3x minus, so we'll say 1 over 3x, maybe 1 over 3x. Okay, let's talk about what is f of g of x. What that means is you take g of x and g of x becomes your input. You're inputting that into f of x. So f of x takes the input, squares it, multiplies it by 2 and adds 1. But our input is 1 over 3x. So we take 1 over 3x, we square it, we multiply it by 2, and we add 1. So that thing there would be f of g of x. Okay. Sometimes written as f after g of x. Okay. There's a little, like a small little circle. It's not an O. It's smaller than that, which they write in. Okay. What if we did just actually the other way around? G of f of x. Maybe pause the video for a quick second and just try and figure out what would that be. Okay, so what are we doing? We're taking g of x and we're sticking in f of x as our input into g of x. So g of x, what you do is you take the input, you multiply by 3, and you do 1 divided by the answer. So what you're going to do is you're going to take the input, which is 2x squared plus 1. You're going to multiply it by 3, and that answer, you're going to divide it into 1. So that's what g of f of x would mean. Okay. Now you can go ahead and do that over here for the example that they've given, if you wanted to. But actually, I don't really think that there's a need to do it. Well, first of all, you can just find out what's g of 8, find that exact number, and then input that number into f of x. I think it's just maybe a little bit easier to do it that way, but you could do what I've just shown you there as well. So f of x, remember, it's, well, actually we should write down what g of x is first. So I've just had a look here. So g of x, there. Okay, so g of x, you can actually just read it from the graph. If you're looking for g of 8, that means that you're inputting 8, that's your x value. So you can see here when you input 8, you get out a value of 4. Okay, you could use the function over here. So I should have called this guy g of x here. So you can, if you want to, throw 8 into that. You know what? It's not a bad idea just to show that the thing that we have here was actually true. They didn't ask you to write this out. You would just, of course, do it from the graph. This is just a chance for me just to check whether I had that right. So we've got 16 over 3 minus 4 over 3. That's 12 thirds. That's 4. Yeah. So you place in 8, you get out 4. So g of 8, we'll do it down here. G of 8 is equal to 4. So what this is really asking is, what is f of 4? As in, go to the f function and input the number 4. Now, do we have an f function? We did. There's our f function all the way back there. Am I going to memorize that? 3 minus 2x over x minus 5. 3 minus 2x over x minus 5. That's what f of x is. And we are getting f of 4. So we're inputting 4. So 3 minus 4 goes in there. We're going to get an 8. We place 4 in there. We are going to get minus 1. So we'll get f of 4 is equal to minus 5 over minus 1. So f of 4 is equal to 5. So f of g of 8, that's just 5. You find out what g of 8 is, get that number, and you place it into the f function. So you place 8 into the g function, whatever answer you get out, you place that into the f function. Okay. What we could have done was we could have got f of g of x. Okay, that would be a little bit tricky here because it does different things at different times. So you would have to look at one case which is between -1 and 2, and another case which is between 2 and 8. I haven't seen them asked that sort of question, but it's just to mention it. Okay, sketch the graph with the equation of y equals g inverse x. So we got to go and take our functions here and actually do it out. So what you can do is you can just use this thing here and go and get the inverse. But also what you can do is you can just use the graph in order to figure it out. Okay, so there's kind of two ways in which you might be able to do this. So I guess we'll do both. Okay, so first of all, what is g of x? I'm gonna write down both things here. It was, first of all, 3x minus 6 when x is between, I think it was -1 and 2. We can change that if we need to in a second. -1 and 2 was 2/3 x minus 4/3. 2/3 x minus 4/3 when x is between 2 and what was it, 8? Yeah. Okay, so you know what, let's go and get the inverse for each particular thing. So if it was y is equal to 3x minus 6, you would say that y plus 6 is equal to 3x, and you'd say that x is equal to y plus 6 over 3, so we now just flip that around. Y is equal to x plus 6 over 3. So this is what g inverse x is. It is x plus 6 over 3 when it's between these two values, -1 and 2. And if we take our other one, y equals 2/3 x minus 4/3. What to do? Multiply everything by 3, I suppose. 3y is equal to 2x minus 4. 3y plus 4 equals 2x. X equals 3y plus 4 over 2. So again, we just flick that around. Y equals 3x plus 4 over 2. 3x plus 4 over 2. And that is when it is between 2 and 8. Okay, so from here, what you can do, I suppose you can go and you could actually do the function thing in your calculator, I suppose. So I've got our new calculator, the 85GTX. So if you are using that, you know what, it's no bad idea here. We'll just take some time out to just remind ourselves how to do a table. And actually, yeah, this is quite nice when we do it. So if you go to menu and you go to number 3, which is table, or you can scroll along, it says f of x equals. So we'll just pick our first one there. We'll say x plus 6 over 3. So use the old fraction line. You're going to have to use alpha, I think. Yeah, alpha and x. That's just where the closed bracket is. So that'll get you the x plus 6 over 3. Press equals. Now normally what you do, g of x comes up here, which is, do you want to put in a second function? Normally we wouldn't. We only ever typically want to put in one function. So you just press equals here to go straight onto it. But in this case, we actually do want to do it. I've actually never used the calculator for this yet, since it's a new model. So let's see, I'm learning with you as we go along. So it says a starting point. Well, we want to start with -1. Now this is interesting. Is it doing it for both things? I suppose it is. So we'll just need to be a little bit careful with that. So we'll start -1, we'll end 8. Maybe it's just better to do each one individually, but anyway, we're here. And the step is going to be 1. And it makes a little table out for us. Okay. So what it says, because it wants us to sketch it, is for our first one, which was x plus 6, so that's the -1 to 2 one. That's the -1 to 2 one. So it says that when we input -1, we get out, maybe I'll do this in horrific red or something like that. we will get, so we place in -1, we get 1 and 1/3, 2/3, sorry. That's like there. We place in 2, sorry, we place in 0, we get 2, should be the halfway point there. We place in 1, we get 2 and 1/3. Now that so far is linear, isn't it? Yeah, it went up by 1/3 because it was 1 and 2/3 up to 2, so that was adding on 1/3. This is also adding on 1/3, and this is also adding on 1/3. Okay, so far it's been linear. To be honest with you, it's probably a little flatter than what I've drawn it. That kind of more looks like it's up at 3. So what? Sorry, it's just kind of hard to judge. So it looks to me like it's maybe a little bit more like this. Okay, we can put in those points as we go along. Maybe actually if we just zoom in, it'll be a little bit easier to draw. Okay, so now it changes over from 2, and when we place in 3, we do get 3. I'm going to say that that's there. When we place in 4, we get 3 and 1/3. When we place in 5, oh no, sorry, look at that, I was reading off the wrong one, which I was thinking that one's just going up just the same as the other. Why is that happening? Sorry, when we place in 3, we get 6.5. God help us as to where 6.5 is to be accurate, or where 3 is for that matter to be accurate. Hopefully they wouldn't ask this sort of question. Next one is when we place in 4, when we place in 4, we end up getting 8. So 4, 8. When we place in 5, we get 9.5. So this is going up in 1.5s. Okay, and it's not that surprising because I think we would have seen that. Now, importantly, when I place in 2, I do also get 2. So it should look something like that. Okay, it should look something like that. Now, I think it asked kind of a strange question. Let's have a little look at it. Sorry, it's still back here. Sketch the graph that showed the coordinates of each point at which the graph meets or cuts the axes. Okay, well, we only had one inside here that I was looking at. And what was this one here? So this is where when we place in 0, we get out 2. Okay, so that thing there is 0, 2. And I guess what we could do is we could figure out, if we're looking at over here, but it didn't specify whether this is just meant to be between -1 and 8 or not. Okay, it's not clear if that is what it wanted. But anyway, look, that's how to do it. If you do want it to go along there, there'd be a fast way to do it. How does it work on the left hand side? The way it works on the left hand side we already have is this. What we'll be looking for, if something crosses the x-axis, we would say that y is 0. So you can say that 0 is equal to x plus 6 over 3. Multiply both sides by 3. You'll get 0 is equal to x plus 6. And x will be -6. So you'll get -6, 0. That's the other place where it crosses the axis, as far as I can tell of what they're asking. Okay, that's a good question to be introduced now to these inverse functions. To be honest with you, if you were able to do that inverse function at the beginning, that is fine. I will go and see if I can find some inverse functions that have come up on the Leaving Cert, and I'll post that. I'll post that in the next video. The one I would like you to try, it's the sample paper. So if you just download the Educate papers that I gave you, I know quite a few of you have been going through those. If you go to the sample paper, it's on page 287 there, but it's a sample paper 2014, and it's paper 1, question 9. This is a great question here. I will do this question out for you. It's part of the long question, so there's more to it. It's not just going there. The C part isn't so much to do with functions. It's actually a very tricky one, but I'll also do that one here. But you can see that this function that they have here is a piecewise function. We've got a sprinter. And I don't want to give much away, but obviously when a sprinter runs, I mean, it's not going to be this either. But the sort of theory behind this is that between vt is his velocity, between 0 and 0.2 seconds, his velocity is going to be 0. So think about what that is going to be. You know, what does that represent in real life? Hopefully what you're thinking of is that's your reaction time, okay, from the gun going off to him actually taking off. Is that between 0.2 and 5, this function here, when you place in any time in between that, this will give you out the velocity. So again, what does that represent? Well, obviously, you know, you're building up speed as you start, hopefully. So this is what's representing that. And then it's saying for t greater than 5, okay, anything after 5 seconds, including 5 seconds, he's just running at a constant rate of 11.52. So the time doesn't come into it there. Okay, I mean, is that actually accurate? You know, it's not a bad model for it. But that's why one function is kind of broken up into 3. It still counts as one function. A bit like the Trinity or something like that. But this one is a good one for you to go and try out. There's a bit of I think there's a bit of integration involved in it and all that. But look, I won't give it away now. Go ahead, go and do it. There's some differentiation as well, I see. Go ahead and do it. In fact, you can do that by a few ways. You don't just have to differentiate. If you wanted to complete the square, if you're a maniac, you can go and do that. You know, that would not be a bad one to figure out. Yeah, I definitely know completing the square. Look, I'm rambling.